Solving a double square root problem is probably in my opinion, it's one of the more difficult things we do. Just because it is long and tedious, not because any one step is going to be difficult, but it's these are just long and tedious problems and you kind of got to get used to them. So, the questions that we're looking at here are something like the square root of x plus 3 minus the square root of x plus 1 is equal to 1. What numbers can I plug into x to solve this equation? Now, because there are two square roots, when you isolate one, which is what you're supposed to do, isolate a square root, square both sides, right? That's how we learned. When you do that, you get rid of one of the square roots, but the other one sticks around. So basically, what has to happen is that we're going to isolate one of the radicals, square both sides. Do not do this where you square each thing individually. That is wrong. You cannot square in things individually when they're added. We just kind of went over that, right? So you're going to square it. Be careful foiling. It's going to get ugly. Then you're going to have another square root problem. You're going to isolate that radical, square both sides again, and keep going. The best way to understand how to do this is to just watch an example. So we're going to start by isolating the square root of x plus 3 and getting that by itself. So we will add square root of x plus 1 to both sides here. So we will get square root of x plus 3 is equal to 1 plus the square root of x plus 1. Now, how do I solve a radical equation? I'm going to put parentheses around the entire left side and the entire right side and square. On the left, the square root and the squared are going to undo one another, and so we get x plus 3. On the right, though, we have a plus sign, so we have to write it twice and multiply. So being very careful, 1 times 1 is 1. 1 times square root of x plus 1 is square root of x plus 1. 1 times square root of x plus 1 is square root of x plus 1. And square root of x plus 1 times square root of x plus 1 is square root of x plus 1 squared. So we get this as our so far, our foiled out answer. Now let's clean this up. So that gives us x plus 3 is equal to 1. Now, 1 square root of x plus 1 plus 1 square root of x plus 1 is 2 square root of x plus 1s. I get students who kind of get to that point and they're like, oh, okay, it's just addition. Add the coefficients on the front. Then this square root squared on the end, we're going to have the square root and the squared undo one another, and we're left with x plus 1. On the right-hand side, we're going to collect like terms. So there's just one x, but we have a 1 plus 1. That gives me 2 plus 2 square root of x plus 1. Okay, if we've made it this far, we're about halfway. Notice that we are at this point just at another square root question, right? We want to get the square root by itself. So I'm going to subtract x from both sides and subtract 2 from both sides so that I get the 2 square root of x plus 1 by itself. And x minus x is 0, 3 minus 2 is 1. So this gives me 1 is equal to 2 square root of x plus 1. Now, the square root isn't by itself, but if I divide by 2, I get fractions, and I don't want to deal with fractions. So we're at this point going to square both sides, and we scaffolded, so you should probably see what's coming here. 1 squared is 1, and then remember, 2 square root of x plus 1 squared means 2 times 2, which is 4, and square root of x plus 1 times square root of x plus 1, which is square root of x plus 1 squared. So we're getting 4 times x plus 1, and at this point, you should be able to finish solving. So this will be 4x plus 4. Subtract, we get negative 3 equals 4x. So our final answer here is x equals negative 3/4. If I was a better teacher, I would say, yes, you need to plug this back in and check it. And you should. I will tell you, I've already done that. And it does actually solve our problem. So, lot of steps, a lot of places this can go sideways. But don't worry. If you just kind of keep plugging along and ask for help and check your answers, this should go